This video is on strong oxidation of alkenes, predicting structures of alkenes using products form. When the alkene end contains two hydrogen, the products formed are carbon dioxide and water. When the alkene end contains a hydrogen and an alkyl group, a carboxylic acid is formed. When the alkene end contains two alkyl groups, the product formed is a ketone. When oxidation of the alkene produces only one product, this means that the alkene is symmetrical. The product comes from an alkene fragment that has one CH3 and one hydrogen. The symmetrical alkene implies that both ends are the same. Thus, the alkene is formed when both ends are joined together. What if the product of the alkene produces two products containing carbon? This implies that the alkene present initially is asymmetrical. Formation of carbon dioxide implies that the alkene end contains two hydrogen, while ethanoic acid produced implies that the other end contains one CH3 and one hydrogen. Joining the two ends give us the structure of the alkene. What happens if the product from oxidation of an alkene gives three products? We look out for the product that shows two C double bond O. The evidence of the last product implies that the alkene has two carbon-carbon double bond. The evidence of a C double bond O in the product shows that this is where the CC bond were. Hence, the last fragment shows where were the two carbon-carbon double bond. How the fragment looks like is based on the pattern for oxidation of alkenes. The blue portion of the product corresponds to the blue portion of the fragment. The orange portion of the product corresponds to the orange portion of the fragment. Since product is a diketone, it means that both fragments are attached to carbon, while the other two products correspond to their respective fragments. The structure of the alkene can be deduced by assuming that A is linked to X. This will be how the first carbon-carbon double bond will look like. Then we assume that B is linked to Y. Hence, this will be the structure of the alkene. Alternatively, we can assume that A is linked to Y. This will show how the first carbon-carbon double bond will look like. Then we assume that B is linked to X. Hence, this can also be the structure of the alkene. However, what if we have a product that contains two oxidized halves? From their corresponding half, deduce their respective alkene fragment. Count the number of carbon atoms between two alkene fragments. This implies that carbon 1 is linked to carbon 6. Hence, the alkene contains 6 carbon atoms, with the carbon-carbon double bond as carbon 1 and carbon 6 respectively. Lastly, take note that a methyl group is on carbon 1. This is the end of the video. Please replay if needed.